Hello and welcome back to PA Academy. So this is example 3. So we've looked at 2 examples so far, and if you missed those examples, I'll leave a link to it in the description of this particular video. So now if you are looking at this circuit, you are asked to calculate the current flowing in each mesh and the current passing through each resistors. Now if you look at this one, now we are having 1, 2, 3 meshes. We are also having 1, 2, 3, 4, 5 5 resistors. Unlike the previous examples that we looked at, we are having 2 meshes and then 3 resistors. So now this is 3, and then we are going to be calculating the currents flowing through each of them, each of the meshes and each of those resistors. So to start with, now let's note the nodes and some of these points. So let's call this A, let's call this point B, let's call this C, this is D, let's call this E, F, G, and then H. So now let's choose our direction of current for each of those for each of the meshes. So like I said, I do prefer to start with a clockwise direction. So in a clockwise direction, let's take our current to flow in this direction. So this is our mesh 1, and the current in this mesh 1, we've taken it to be I1, and then this is our mesh 2. So this is mesh 2, and then the current is what is I2, take it to I2, and this is mesh 3, and then the current here is taken to be I3. So now the next thing for us is to give it to the polarities. So let's start with the voltage source. So the longer side positive, and they will be negative, and this will be positive and negative. So having done that, so the next thing we have to do is to add polarities to the resistance, to the resistor. So in the direction of current for this I1, we are going to be having plus, minus. So this will be giving us plus and minus, and then, so let me indicate this very well. This is plus, this is minus. For the voltage source, the longer side is positive. So this is for the mesh 1. So now let's go to the mesh 2. For this 2 ohm resistor, this is going to be plus, minus, plus, minus. Then this is going to be plus and minus, and that's max is for the mesh 2. So let's go to the mesh 3. This is going to be plus, minus in this direction of current. So this will be plus, minus, and then remember I said the voltage source, the polarity is not influenced by the direction of current. So now that we've been able to have this, analyze this on our circuits, let's go ahead and solve the question. And remember that we are going to be using mesh analysis to calculate all of these things. It's very important. Mesh analysis, that's what we are using. So we are going to be applying Kirchhoff Voltage Law to each of these mesh. So let's start with mesh 1. So let me write it for mesh 1. And mesh 1, the parts that for mesh 1 is A, B, G, H, and then back to A, like this. Mesh 1. So now let's apply KVL to mesh 1. So now from point A, if you take it from point A, the first element you are going to be coming across is this 1 ohm resistor. So from positive to negative, you can see the polarity from positive to negative, that's going to be minus. Then the current is I1 multiplied by the resistance, or in the resistance in the 1 ohm resistor, which is 1 ohm. So that is going to be minus 1 I1. So you can also write that as minus I1. So if you should continue, then the next one is this 2 ohm resistor. So in this direction, this is from plus to minus, and we have a 2 ohm resistor and the current of I1 flowing through it. So that is going to be minus 2 I1. Also, we have another current I2 that is also flowing through this 2 ohm resistor, but we are taking it from the direction of I1. But look at the polarity here, from minus to plus. That's going to be plus 2 I2. So this is how you write it when you're having an element or a resistor that we are having that is in between 2 meshes, where we have 2 current that is flowing through it. So this is how you go about to indicate it. So from G now we come to H. From H to A, we have a voltage source, and that is from minus to plus. So that is going to be giving us plus 5 volts and equals to 0. Now remember, the 5 volts, we are not going to be multiplying it with the current because this is already in voltage. Alright, so now let's simplify this. If you look closely, we have minus 1 and minus 2 I1. So that is going to give us minus 3 I1 plus 2 I2 equals to minus 5. And what we are having here, we take it as our equation 1. So this is our equation 1. We note that. So now let's go to mesh 2. So now let's go and simplify that of mesh 2. So let me write it here that for mesh 2, now the path for mesh 2 is B, C, F, G, and back to B. That will be B, C, F, G, and B. So now let's apply Kirchhoff voltage law to that particular mesh. So starting from B now, from positive to negative, that is going to be minus 3 ohm resistor multiplied by the current I2, that will be minus 3I2. So when we get to C, between C and F, we have a 4 ohm resistor. So from positive to negative, that is going to be minus 4I2, minus 4I2. Also, we have another current that is that's the current of I3, but this time we are still considering the direction in this mesh 2. So that's from minus to plus. So that will be plus 4, this time I3. No, now from F to G, there's no element there. Now between G and then B, we also have a 2 ohm resistor. So from plus to minus, that is going to be minus 2I2. Also from minus to plus here, that is going to be plus. Then the current in it is you are looking at the I1, that will be plus 2I1. All right, so and we are going to be having equals to 0. So by the time we simplify this, let's look closely. The ones with let's start with the one with I1. That is going to be 2I1, this one. Then what about I2? We have minus 3I2 plus, minus 3I2, minus 4I2, and minus 2I2. So that's going to give us minus 9. Minus 9I2, and then plus 4I3 equals to 0. Now what we are having there is our equation 2. So this is the equation that we are having from our equation 2. So now let's look at mesh 3 now. So mesh 3. So the path for mesh 3 is C, D, E, F, and back to C. So that will be C, D, E, F, and back to C. All right. So let's also apply Kirchhoff voltage law to that mesh 3 and see what we are going to get. So starting from point C, also in a clockwise direction. So from positive to negative for this 5 ohm, that is going to be minus 5, and the current passing through it is I3. So from D to E, we only have a voltage source, which is from positive to negative. That's 10 volts. That's going to be plus 10. Remember, it's a voltage source, so that will just be 10. So from E to F, there's nothing here. From F to C, we have a 4 ohm resistor there. So from positive to negative, this is going to be minus 4I3. Also, from negative to positive this time around, that's due to I2. So that is going to be plus 4I2 equals to 0. So now let's simplify this. So we are having 4I2, that's this 4I2, and then I3, we're having minus 5I3 and minus 4I3. That's going to be minus 9I3. Then this plus 10, if you should take it to the other side of the equals to sign, that is going to be giving us minus 10. Now what we are having there is our equation 3. So now that we've have these 3 equations, what we are going to do next is to solve equation 1, equation 2, and equation 3 simultaneously. So what it simply means is this: if you are to solve them simultaneously, so let me write it out for you. So we are going to be having minus 3. So we are going to be having minus 3I1 plus 2I2, then plus 0I3 equals to minus 5. Now you can see that I3 is not in this equation, but having plus 0I3 is still the same thing as 0. The only reason why I'm adding it here is so that if you are trying to use your calculator to get your answer, it makes it much more easier. So for the third part, if you are using your calculator, this part you just put 0 there. You just put 0 there. So if you are familiar with how to use scientific calculator, you understand what I'm saying. So now for this equation 2, then we are going to be having 2i1 minus 9i2 plus 4i3 equals to 0. Then equation 3, we don't have i1, so you can just indicate it as 0i1. You know, the same scenario here is what happened here, that we're having is 0. So this is 0i1 plus 4i2 minus 9i3 equals to 0. So if you should solve these three equations simultaneously, what you are going to be getting with that to give you the value of i1, i2, and i3. So all things being equal, so let me just write it here. So all things being equal, you are going to be having your i1 will give you 1.54 amperes. Remember to always add your units. Your i2, it will give you minus 0.189 amperes, and then your i3 will give you minus 1.195 amperes. So with this now, we've been able to get our i1, i2, and i3. So let me rub this off. If you want to note this down, you can kindly pause the video and write out the calculation we've done so that we can have more space to analyze the question further. All right, so let's continue. I've write it here, i1, i2, and i3. Now, if you look closely, you can see that for i2, we are having a negative value, and for i3, we are having a negative value. Now, we're experiencing something like this when we are looking at example 2. Now, the reason why we're having a negative value for the current that is flowing through i2 is simply because we assume a clockwise direction for this mesh 2. We assume a clockwise direction. So what it means is that the current in this mesh 2 is actually flowing anti-clockwise. You can see it's flowing anti-clockwise direction against the direction we assumed. Same thing applies to i3. So that means the current is flowing in anti-clockwise direction. But for i1, we assume the current is flowing in clockwise direction, and we got a positive answer. That means our assumption is what is correct. So that's the value for i1, i2, and i3. So if you want to just go further to indicate something, you can just indicate that, okay, you choose in calculating for your i2, you took your direction in a clockwise direction. Same thing for i3, clockwise direction. So it might just guide whoever is looking at it that, okay, you took it in a clockwise direction. That's why you are having a negative answer. So now we've been able to answer the first part of the question that says calculate the currents flowing in each mesh. Now we have to calculate the current that is passing through each resistor. Now if you look at this circuit again, we're having 1, 2, 3, 4, 5 resistors. So we have to calculate the current that is flowing through each of them. So now to start with, let's start with the current that is flowing through the 1 ohm resistor, which is this one. So the current there, we are going to represent it with, that is the current I for the 1 ohm resistor. So this is how I'm going to represent it. Now if you look at the circuit closely, you see that the current that is flowing through I1, that means flowing through the 1 ohm resistor is definitely I1. So current in 1 ohm resistor is also equals to I1, and we've gotten the value of our I1 to be 1.54 amperes. So when you are indicating the current that is flowing through the elements in the circuit, always indicate the direction. Now remember, we choose a clockwise direction. So when we get here, the current will be flowing like this. You can see like this, based on the position of the elements. When it gets here, it is towards the right. So always indicate it. So we are going to be having direction like this. That's for the currents in the 1 ohm resistor. So now let's look at that of the 3 ohm resistor. So we are going to be having the current in the 3 ohm resistor. So in the 3 ohm resistor, if you look at it, the current that is flowing through it is just only I2. So you can see only I2. So if you look at I2, the answer for I2, we've got our I2 to be minus 0.189 amperes. But this time around, we are not going to be writing it with the minus. So let me first indicate that the current flowing through the 3 ohm resistor is also equals to I2 rather. It's the same thing with I2. And the value for I2, though we are getting the negative answer, but we are going to write it in positive. So that will be 0.189 amperes. Now, this is the direction that we assume that gave us the negative answer. But now that we are indicating it without the negative, we are going to take it in the opposite direction. Is that clear? So if you are taking out the negative sign, then make sure that your direction will be opposite. Now if you want to write it like this, if you want to have it to be minus 0.189 amperes, then that means the direction is going to be like this. I hope that is clear. So if you want to still write it like this will be your direction. But if you're writing it without the negative sign, the direction will be like this. All right, so let's continue. So let's do that of current flowing through the 5 ohm resistor. So for the 5 ohm resistor, the current that is flowing through it is I3. So that's equals to I3. So the same explanation here is what applies to that of the 5 ohm resistor. We've got our I3 is a negative, but we are going to be giving it in positive. That will be 1.195 amperes. So the direction for it, the direction we assume here is a clockwise direction. This was the direction we assumed. But since it's giving us a negative answer, we are going to move it to indicate it here that this is the answer, but in what? In the opposite direction that we assumed. All right. So let me know if this explanation is clear, especially for the current in I3 and then the current through the 3 ohm resistor and the 5 ohm resistor. Do let me know in the comment section below if you have any question with the explanation I've done here. So now let's go ahead and calculate that of the current that is flowing through the 2 ohm resistor and the 4 ohm. So start with the 2 ohm. Now, like I said, if in the previous example, that if you have an element that is between two meshes and you're having two different current that is flowing through them. Now, what will determine this is this. Since we have two currents, I1 and I2, it's either we are going to be having I1 minus I2 or we are having I2 minus I1. And I said it before that what is going to determine either we are using this or this is which of the value is higher. So if I1 is higher than I2, we are going to be using this. If I2 is higher than I1, then we'll be using this. So now let's look at our answer again. Between I1 and I2, which one do you think have a higher value? Between I1 and I2. Alright, so if you look at it closely, the one with higher value is definitely I1. 1.54 is higher than minus 0.189. So that means we are going to be applying this. So if you apply this, I1 minus I2, so we are going to be having 1.54 minus, and remember this, the value for I2 is minus 0.189 amperes. So let me also indicate the amperes here. So that's going to give us 1.54 amperes plus 0.189 amperes. And that will give us, so let me see that in the calculator. So that will give us 1.7729 amperes. 1.729 amperes. So don't forget, always indicate your units. Always indicate your new unit is very important. So we've gotten the current that is flowing through the 2 ohm resistor. So now let's calculate that of the 4 ohm resistor. So the same thing that we did here is what we are going to be doing here. So there are two currents flowing through it, I2 and I3. So it's either we are having I2 minus I3 or we are having I3 minus I2. So what will determine the one we have to use is which one have a higher value. So if you look at our answer again, between I2 and I3, which one do you think have a higher value? Remember, they are both negative. So the one with higher value is I2 minus 0.189. Please don't make the mistake of saying because this is 1 point. If you're having a number in descending order, let's say from 3, 2, 1, 0, minus 1, minus 2, minus 3. Definitely minus 1 is higher than minus 3. Exactly. Alright, so the one with the higher value is minus 2. So that means we are going to be using this. So minus current in I2 minus that of I3. So we are going to be having minus 0.189 minus, so into brackets, minus 1.195. I have to put this in bracket because we are having two negative sign. So if you are to compute this, you are going to be having minus 0.189 plus minus times minus plus 1.195. So if you should simplify this, Remember, this is also the same thing as writing 1.195 minus 0.189. So if you should calculate this in your calculator, you should be having 1.006 amperes. All right, so let me be sure you're still seeing it. All right, so you are still seeing it. All right, so there's one thing I didn't indicate here is the direction for this current. So let me first of all complete this. Now we've gotten the current that is flowing through the 4 ohm resistor to be 1.006 amperes. Now for you to determine the direction, you pick the direction of the one with the higher value, which is I2. So if you look at the direction for I2, since we are using the one with the negative, so I2, so that means the one for I2 is what? So the current in I2, yeah, so if you come like this, okay, the 4 ohm resistor, you can see it's going downward towards here. When it gets here, it's downward. The current in I2. So it's going to be in like this. I hope that is clear. So now let's look at that of the current that is flowing through the 2 ohm resistor. This is the 2 ohm resistor, and we've gotten to be I1 minus I2. So that means the higher value is I1. So the direction of I1 is the direction that we are going to give to our final answer. So let's look at the direction for I2 with respect to the 2 ohm resistor. So when you get to this is I1, when it gets to I2, you can see it is facing downward. So this is going to be the direction. So I hope all this explanation is clear. So with this, so before we go to example 4, so with this now we've been able to do justice to this circuits that we are asked to calculate the current that is flowing through each of these the mesh, and we've gotten the current in each of them. This one, as you take it to I1, I2, I3, and these are the values here. We've also been able to calculate the current that is passing through each of these resistors. This is that of the 1 ohm resistor. We've gotten it to be 1.54 amperes. That of I3, we've gotten to be 0.189 amperes. That of 5 ohms resistor, we've gotten to be 1.195. And these are the directions. And this is that of the 2 ohm resistor and then the 4 ohm resistor. So if you find value in this video, please give it a thumbs up. Make sure you like and also share this video. If you have any question, any doubts or whatsoever, just leave them in the comment section below. So with that, I'll see you all in the part 4. And also you can also check out our website paacademy.co. So thank you very much, and I'll see you all in the next video. Thank you.